Okay, let's get started. Hello, everyone. Hello. Welcome to the shop. I get these headphones on so I can sound at least a little bit normal from my own perspective. It appears that the green screen. Let's go ahead and change that real quick. Oops, that is not the green screen. There we go. So, I'm just going to need to change this a little bit. There we go. Now I won't have little black pixels all over my face and whatnot. So let me get this going. All right, as the title suggests, we're going to be playing some video game. Just kidding. We're not playing video games today. Today is not a video game stream. If you came here looking for video games, turn and run. That is not what we're doing today. Today, we are playing. We're using a program called FreeCAD. For those that don't know, who aren't a part of the engineering scene, computer-aided drafting is where you make engineering parts in a computer. Very, very simple. It's kind of akin to Blender. I know a lot of more people. It's like the generic freeform, like that's like the most obvious one. Except it's very, very different. They do the same thing, but they do it very differently. Blender is what's called a mesh-based, we're just going to pop on the screen here. Blender is a mesh-based 3D modeling tool, and FreeCAD and other computer-aided drafting software are typically parametric-based, which means they're more geometry-oriented rather than mesh-oriented, like a video game would be. So, I just wanted to, so, if you don't know my background, I'm an aerospace engineer. I graduated from my college not too long ago, but there are a lot of skills that I don't have that are very beneficial to being an aerospace engineer. One of them being computer-aided drafting, and another one being finite element analysis. So, yeah. I will be focusing on the computer-aided drafting. This program that I'm using is called FreeCAD. It does both. I don't know how good it is at finite element analysis, but my god, I am sure going to try to learn how to do it regardless. But that's not today. Today we're going to be focusing on the computer-aided drafting part. And they have a plethora of tutorials that I'm going to go through. And just like kind of follow along. They are right here. These are the tutorials. Hello, tutorials. I've already done these two right here. These were kind of straightforward and pretty boring for a stream setting, so I'm going to just not bother going over them in any way, shape, or form. We're gonna start with the Lego. We're gonna start with a Lego today. And this is just on a Wikipedia page. You can just search it up. It's really easy to find and super cool because I have found it within the last 30 seconds of me trying to get my stream together. Took no more than 15 seconds for me to find, and that was super good. Okay, so blah 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 blah. Start by modeling a cubic shape. Blah 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 blah. Okay, so if I recall correctly, I don't remember how to use this at all. It's been a while since I've used it. And even the only experience I have with it is those two tutorials that I did. So I'm just gonna take some fully based on sketches 2D, blah 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 blah. blah, blah, blah. For example, you can place a vertical constraint on a line segment to force it to stay vertical. Yes, I know. This should be avoided. FreeCAD will notify. Yeah, sketches have an edit mode, blah. Let's start by only part design workbench. Okay. Click on the new sketch button. New sketch. Here we are. A dialog will appear where you want to lie the sketch. Choose the XY plane, which is the ground plane. The sketch will be created immediately, and yeah, so the XY plane. This is the ground plane. We're looking at it from above. This is what's over here. XY plane. Okay. Sketch will be created when you switch to edit mode, and the view will be rotated to look at your sketch orthogonally. I think I did that. Now you can draw a rectangle by selecting the rectangle tool. Yeah, okay, we're on the right viewpoint. And clicking 2 corner points. Boom, done. Easy, easy so far, easy. You notice that a couple of constraints have automatically been added to our rectangle. Vertical segments have been received a vertical constraint, and the horizontal ones a horizontal constraint, and each corner a point-on-point constraint that glues the segments together. So these corners have been such that they are automatically together, all of them, and then these 2 lines are set to be vertical, and these 2 lines are set to be horizontal, which is exactly what we want. 3 more constraints. Select one of the vertical segments and add a vertical distance constraint of 23.7. Go here. Oh. I should be able to do it this way, right? Yeah, there we go. And then we want 23.7 millimeters, right? There we are. And then the horizontal, we want 47.7. Click here, we click horizontal. We go 47.7. There. Finally, select one of the corner points, then the origin point, which is the dot. And add coincident constraint. Yeah. Hey, seriously, how's it going? We're learning. So click here, and then do coincident. Yeah, it's a little different on the wiki. There we go. The funny thing is that a lot of the movement controls for this, like moving the camera around, they're the exact same as Stellaris of all things. So it makes it really easy for me to be able to transition. When I first started using this, it was back when I was doing Stellaris a lot, even in my free time. So I was like, oh yeah, I need to move this. And I automatically just went like this without thinking about it. And it worked. Now, obviously, in Stellaris, right-click is rotate. And that's not the case for this. It just brings up this menu. To rotate, you have to do this motion, viewpoint-based rotation. So I could, like, do this. Yeah, front. This is what it looks like from the front. Perfect. But we want the top views. Okay. That the point constraint is not absolutely necessary. You are never forced to work with fully constrained sketches. However, if we are going to print this 3D block, or this block in 3D, so this is for 3D printing, it will be necessary to maintain our piece close to the origin point. Which is the center of the space where the printer head can move. Yeah, so for a piece this small, it doesn't matter where you place it with respect to the origin, so long as it's not way out far away from the origin. But for bigger pieces that start to take up the size of your 3D printer itself, you kind of want to make it to where it's like centered. So I could, instead of doing that, I could do like a horizontal distant constraint between this point and the origin, and set it to be like 20, and just have it be somewhere in the middle. The origin be somewhere in the middle, so it's as centralized as possible. There's other ways I could do it too. I could make it to where it's exactly centered between these 4 lines. I could draw diagonals here and then have the crossing point of the diagonals be coincident with the origin. Hey Fives, how's it going? I knew I would get you engineering nerds out here. I have experience with this kind of thing. I am 100% not qualified to call myself proficient in it, though, which is why I'm here learning it. I'm just bouncing back and forth between the tutorials. Creating the sketch is the easy part. Turning it into something valuable is the more difficult part. Right now, we are making a Lego, because that's the tutorial provided to us by FreeCAD itself. And we have made a rectangle so far, so we're doing good. We at least recognize that Legos can be rectangles. Our base sketch is now ready. We can leave edit mode by pressing the close button on top of the task panel, or simply by pressing the escape key. If needed later on, we can re-enter it. So I can hit escape, and we have a rectangle. Who did? It's going, but guess who got COVID? Did you get COVID? I hope you didn't. I hope you're well. I mean, knowing you, you're probably well. You'll probably feel sick, but there's no risk to your life. In fact, no offense, but I do hope it's you over someone who is more frail in your family. Because I know how mighty you are and how much you can handle it. Okay, so we have our rectangle now, and it's probably going to tell us to do an extrude next, right? Our base sketch is now ready. We can edit by pressing the close button. Yeah, let's extrude it by using the pad tool. Give it a distance of 14.4 millimeters. You did, but I'm making it through okay. Yeah, I figured as much. Yeah, you're a hardy man. And then, thank you. Then we have this. This is the pad tool, right? And we want to make that length. It was 14.4, I want to say. 14.4. Other options can be left at their default values. Awesome, cool. Okay. So now if I do this, that's the front view. The bottom view, it's just a regular old cube. Alright, I could go with like an orthogonal view here, and then you could see it better. Yeah, this is probably a better view. Actually, this isn't technically an orthogonal view, but we're gonna... Maybe it is, I don't remember. There's another one. Isometric, yeah. It's one of those two. I don't remember. You couldn't pay me enough to remember either way. So yeah, we've got the pad going. I think I actually just did this. Yeah, I was just fooling around right at the beginning. I couldn't figure out what to do. But luckily, there's a tutorial for me. Okay, very much like extrude tool that we used previous chapter. Yeah, I've used extrude before. There are a couple differences, though. The main one being the pad cannot be moved. It is attached forever to its sketch. If you want to change the position of the pad, you must move the base sketch. Ooh, spicy. In the current context, where we want to be sure nothing will move out of position, that's a degree. Okay, so yeah, if we move the sketch, the pad will follow. Carve the inside of the block using the pocket tool, which is the part design version of part cut. Okay. To make a pocket, we will create a sketch on the bottom face of our block, which we'll use to remove a part of the block. With the bottom face selected, press new sketch button. Okay, so I need the bottom face. The bottom face, we want new sketch there. Make another rectangle, what it's going to tell me to do. We will now constrain the rectangle in relation to the bottom face. We need to import some edges of the face using the external geometry tool. Use this tool on the 2 vertical lines of the bottom face. Nice. So I think what we need to... This is it. So I think There we go. And then... When you create a sketch with a face selected, a relation is created between that face and the sketch, which is important for further operation. Okay. It's not real. It will be hidden. Give edit mode, but we place constraints. Place the following 4 constraints. Oh. So it tells me to only do these 2 lines. And then it tells... Okay, I guess I don't need it. Yeah, because it's the points. Okay, okay. And then now we use these. Go here and here. Right? There we go. And that needs to be 1.8. Oh, everything needs to be 1.8. That's good. Can I get orthogonal here? Ah, nope. I can't get a diagonal view. Oh, yes I can. There it is. Okay. So if I try to click here and then here... Select the top left point of the rectangle and the top point, the imported line. Oh, okay, so does it have to be the points? Can I not do the lines? There it goes. Okay, I cannot do the points. They have to be the lines, so I can actually go back to this view now. And then we need a 1.8 here. A 1.8 here. We need now we need to switch to this vertical point, make it 1.8 as well, and then 1.8 here as well. And now it should be fully constrained sketch. Yeah. Yes. Fully constrained means that it's not gonna. It exists. It's good. We did good. That's what it means. Okay, now, fully constrained. Leave edit mode, and we can perform the pocket operation. Yep, so we can leave edit mode. And then we turn it into a pocket. And we make the length 12.6, which is a thickness of 1.8. Yeah. 12.6. And then if I go to a diagonal look here, we have a big pocket. Go to it. Yeah, that's a pocket. That's a pocket. We have pocketed that. That is a pocket. Okay. We now start to attack the... We will now attack the 8 dots on the top surface. I think they mean attack as in, like, we're gonna try and tackle this problem, I guess. Since they are a repetition of the same feature, linear pattern tool, the part design workbench. Model once and repeat the shape. That's perfect. Start by selecting the top face of our block. So we go back to the top view over here. This is the top face, right here. Select it, put a sketch down. Right, yep. Create 2 circles. This is not a circle. Here we go. 1, 2. Hey, looking like a Lego already. Looking like... This looks like Plank from Ed, Edd and Eddy. That's what it looks like. For each circle, select it and add a radius constraint of 3.6 millimeters to them. Should be here, right? Oh, that was close. 3.6. And then that was less close. 3.6. There we go. Import the left edge of the base face with the external geometry tool. Got it. The external geometry of this one, right? There we go. And then set vertical and horizontal constraints so they look like that. Got it. It's all 6 millimeters, so I can just do that. Yeah. Oh, no. We need to... Stop it, villain. Ugh. There we go. There we go, and we go here. Make that a 6. That a 6 as well. There we go. Once again, when you lock the position and the dimensions of everything in our sketch, it becomes fully constrained. It has been fully constrained. Here's the little thing right up in this corner right here. And pad of 2.7 millimeters. Got it right there. Leave the sketch. And then create a pad of 2.7 millimeters. If I go to the side view, there they are. And then instead of having to do that 4 times in a row with different lengths, as earlier with the pocket, since we use the top face, our base block as a base in the last sketch, or any part design operation we do with the sketch will correctly be built on top of the base shape. Nice. So they're directly from the thing, and they will not move. If you of always building one step on top of the previous one, you are actually building one final solid object. Yes, that is true. We can now duplicate our 2 dots 4 times, so we get 8. Select the latest pad we just created. Press the linear pattern button. This is new. So select this pad. Is that this? Linear pattern? Is that what it's called? Yeah, that's it. Give it a length of 36 millimeters, the total span we want our copies to fit in the horizontal axis direction, and make it 4 occurrences. Okay. So it's a 36? Yeah. 36. Here's, and we want 4 occurrences. Ah, it looks great. Ah, this is Lego. We've created Lego. Yeah, just not a duplication of an object is a feature of our shape that has been duplicated. Final object is still only one solid object. Important. Okay, so then we hit OK, and that's done. And this is now Lego, except it's not, because we have to put the little things in the bottom here. Everyone knows that real Legos have the little tubes in the bottom. It's just science. So we select the face at the bottom of the hollow space. So this face in particular, go new sketch, draw a circle. Not that big of a circle. There we go. It doesn't matter where it is at this point in time. Radius of 4.8825. That's important. That's important, kids. Get your dimensions right. 4.8825, right? Right. 4.8825. It's gonna stick out over here a little bit. I don't care. And then once again, do this thing where we go here. Anyway, there we go. And we get the external geometry tool, and we grab. Oh no! Ah! I don't want to use that. There. Okay, we have external geometry again. There we go. I don't have to worry about that. Now we have to redo the geometry of this. 4.8825. Okay, and then we grab... It's 10.2 on both sides. So it doesn't really matter which one I start with. 10.2 here. Switch over to the vertical distance. 10.2 there. There we go. All dimensions can be moved, of course. Make it look prettier. Or just to be annoying. Trouble selecting features. Hiding part of the model can help. To hide a feature, select it from tree and press the space key to toggle visibility. Create a linear pattern from... Okay, wait. Okay. Okay, yeah. So we're done with the sketch itself, so we can close that. And then we add it at 12.6. Right? And then we on that pad. And we do linear here. 24 millimeters and 3 occurrences. Oops. There we go. Simple enough. Okay. Nice. Yep, and that's exactly what we have. I can, from this, show it. Or here. Oh. And you can't see it from here, of course, but you can see it from down here. Next, we have to do the same thing, but there we go. Okay. Now let's make the final holes. Select the circular shape, the circular face of the first of our 3 pins. Okay. Port the circular border of our face. Select that. Create a new sketch. I'm just going to pretend like I know what they're saying. I keep forgetting. Okay. Here we go. Oh, I think it means import geometry. If I do that, yes! Ha! Yes, it's purple. Okay, yeah, that's what it means. Ahaha! Okay, make the geometry. It said 3.6. Perfect, right? Yeah, and then it's got 2 degrees of freedom that'll be solved by making these points constrained. Boom. Fully constrained. Perfect. And then it's going to be the exact same thing all the way through. So if I go ahead and close the sketch, make a cut, a pocket. It's still 12, right? 12.6, yeah. 12.6. And then take that pocket and make a linear void out of it. 24 is the magic number. And then we make the occurrences 3. And then if we like take a look, hey, we have created a Lego. What appears in the tree view has become quite long. This is precious because every single step of what we did can be changed later on. Adapting this model for another kind of brick, for example, one with the 2x2 dots instead of the 2x4, can be a piece of cake. We would just need to change a couple dimensions and the number of occurrences in linear patterns. We could easily create bigger pieces that don't exist in the original Lego game. They call it a game, which is interesting. But we could also want to get rid of the history. For example, if we are going to model a castle with this brick, we don't want to have This whole history repeated 500 times in our file history. There are two simple ways to get rid of the history. One using create simple copy tool from part workbench, which will create a copy. Nice job. With that, I gotta focus back on schoolwork. Alright, don't push yourself too hard, man, especially since you're sick. Hopefully you can get better soon. I believe in you. You got this. As a piece, as a step file, and re-importing it. Oh! We're gonna assemble things! Okay, but first and foremost, save as Lego _ tutorial. What are you doing? Of all the people, seriously, I did not expect that to come out of your mouth. Your mouth, of all, well, from your keyboard, I guess. You type that string of letters to produce that. I've got a problem, guys. Can we just talk about this problem for a second? It's a problem with my father. You see, he keeps buying me these dang almonds, and I can't help myself. This is now an almond eating stream. Almond break. Thought you were going to stay it for sure. I wasn't in that headspace, man. My almonds. I could make this awful by just every first crunch is with the mouth open. Is that vile or what? Unbearable or only meh? I can't tell. I'm the one doing it. Okay, anyway, we gotta make sure to save this. The part has been saved. Okay. Save the file as it is now, yep. Mildly uncomfortable. That's how, I think that's how most ASMR is, isn't it? Mildly uncomfortable. If it's done right. If it's done poorly, it's god-awful and terrible. And re-import. You know, otherwise exporting the piece as a step file and re-importing it. But the best of both worlds also exists, which is Assembly 2 Workbench, an add-on that can be installed from FreeCAD add-ons repository. The workbench is named 2 because there is also an official built-in assembly workbench in development, which is not ready yet. Ooh. The Assembly 2 Workbench, however, already works very well in construct assemblies. Nice. If it's done right, it isn't uncomfortable. That's yeah. I'm not an ASMR guy, so I think it's all pretty uncomfortable to me. And also features a couple of object-to-object constraints, which you can use to constrain the position of one object in relation to another. In the example below, however, it'd be quicker and easier to position the pieces using draft move and draft rotate than using assembly 2 constraints. Save it as it is now. Install the... We'll do that later. Is that all that's left? It is all that's left. Okay. We did it! We made a Lego! I don't want to have to go through the process of installing weird stuff and then troubleshooting it and then blah 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 blah. So we're just gonna pretend that this section from here down is just non-existent. So if we have created Lego, I'm gonna try something. And what I'm going to try is making Lego that is not the same dimension, right? So I guess what I have to do is start with the initial pad itself, right? Hello. There we go. So if I start with the initial pad itself, oh, wrong way. Again. There we go. And just make it. It should be like 2. We'll make it a 2x8 instead of a 2x4. How about that? So it's going to be 2 times as big, right? And that way, we'll take this. So we need it to be. We actually need to go into the pad here, into the sketch, and change this 47.7 into. It would be 95.4. 95.4. That's double the length. Right? Oh, come on. There we go. And then we hit close. And then we've got this weird looking thing, but if we actually take a look at the bottom here, the extrude actually went with it, because it's based off of the distance between here, which is super, super good. It makes everything really easy, and that's what they were talking about earlier. So we actually don't need to do anything with the pocket. We do need to change the linear pattern of the pad, but we don't actually have to change the pad itself. So, instead of 36, I'm pretty sure we can just double that to, 72. I don't know if that's right. And then we increase the number of occurrences to 8. Nope, it didn't work. Yeah, so it's actually a little bit more than that. I think I have to add. I was multiplying the total length by 2. I think I have to add from here to here, whatever that is, right? So, is there a ruler? Yeah, there is. So, basically I need to add 36. It should be total length times 2. So, let's look at the linear pattern. So, the linear pattern is 36 millimeters exactly. I can assume that means it's from this center point to this center point, right? Sounds about right, right? Which means actually, no. I was about to say something dumb. Maybe I'm not dumb, but I feel dumb. Because you can stack 2 on top of a 2x8. Yeah. I can, but there's this extra distance that I have to worry about, right? That's here. Because if just be total length times 2. If you're talking about this 36 right here, that's not the total length. That's this distance here. I'm on the linear pattern part, yeah. So that's this, right? I have the total distance. I'm doing the linear pattern. And that's the only thing I have to change is the total distance, the linear pattern of the top, and the linear pattern of the tubes in the bottom. And that's it. Well, there are 2 linear patterns in the tubes in the bottom, but I have to change both of them. Yes. And it's not just double. There's this little piece right here in the middle that's missing. The length of the long side, yeah. The length of the long side's already been doubled. It's already good to go. It's just a straight multiplier, which is easy. I know what to do. Make it easy on myself. If I click on this pad here, and I go into the sketch, 6 millimeters, which means it's 6 millimeters to the halfway point as well, right? I want to say. Which means it should be 6 millimeters here. I feel like this isn't right. No, I'm doing this a really stupid way, I think. If it's 36 for 4, it would be 84 for 8. Why? I mean, that makes sense. But I want to know why. Maths. Yes. Yes, I understand that there's math involved. So the 36 is from here to here, right? 12 between each. Oh, yeah, so there's 12 from here to here, here to here, and then here to here. And then if I keep going... Oh, now there's going to be 7 gaps instead of 3. That's the math I needed. Thank you. Thank you. So I can go into the linear pattern now. And then it's going to be 84. I feel like that's right, but does this distance look the same as this distance? Whoa! What did I do? Oh, wait. Wait. There it is. Got it. Somehow this changed. Can I just delete this, please? Thank you. I wish I could see the center of this circle. Oh, I have an idea. Here's an idea. Here's how we check. Go to the top view. Let's click on this face exactly. We can actually do another thing here, and we can actually import geometry from both of these. This circle here, this line, and I can then click here and here. And it's 5.4 versus over here where it's 6. So it's not right. Ah! Why is it not right? Did I do the math wrong? On the making it twice as... So I'm actually going to delete this. Don't need it. I was just for measuring. Right? But if I look at this pad here, right? And the sketch, underlying sketch. The original dimension was 47.7. 95.4. No, wrong button. There's no pride in this stream. Why is it... Why is it exactly 47.7 in the first place? That means that if we go back to the original one, right? If I just quickly... I can undo what I've done, and that's fine. 36 and 3. No, sorry, 4. There we go. Okay, and then I go back into the sketch here, and I just cut this in half. 47.7. And then I go close that, right? And then I click on this surface, I create a new sketch, I import new geometry. There's probably a very easier way to do this, and then I do this. 5.7. It's still off. It's wrong. These pieces should be perfectly symmetrical. If I go here, right? Click here and then click here. That's 6. That's correct, right? 6 is what you want it to be. You don't want it to be 5.7. Which means this design is wrong. If I go to the bottom here, it's going. It's weird. Okay, there we go. If I do the same thing here, right, and I just like click on this circle and then do new sketch, and then I external geometrize it, do this, right, and then I do this here and here, 11.7. But on the other side, if I go back over to this geometry tool here, we do these at the same time, actually. That work? I'll just choose whatever. I don't care. There we go. Oh, I can just use that actually. There we go. Here, it's 12, right? So these are also off. So what did they do wrong? They either did wrong the distance between this center here and the edge. It should actually be centered. Or, even worse, they made these the wrong size. In which case, they actually need to be shrunk down a little bit to make these symmetrically 12 each. Likewise with the top. 48 millimeters? What's 48 millimeters? The piece is actually supposed to be 48 millimeters. I'm guessing you went and grabbed one. Almonds, man. I don't know what it is, but I crave the almond. No, but the math checks out. Yeah. But the dimensions that they used were the actual dimensions of a Lego. Like, I can actually look this up. .32 millimeters by 16. .6 millimeters. The length and width of are 8 millimeters. So it's 16 and, yeah, 32. Which means the ones that we made are ginormous by comparison, no? Am I to assume that this engineering drawing is perfect? No, I am not. Because I have no idea what piece this is supposed to be. This is like 8 different pieces. In Lego units, 1.6 millimeters is one Lego unit. You have learned something new every day. This is 5 Lego units. (5√2 minus 3). That's a pretty interesting number too. Just check the patent. Just check the patent. Right? How the hell do I check the patent? Seriously. There are patent offices. Do I just search up Lego brick patent? I am going to assume that Google is right. And that the actual dimensions are 1.6 in Lego units. Because I'm not going to do this nonsense. So in reality, we need to go to our pad here. Sketch. And this actually needs to be 16. And this actually needs to be 32. Wait a minute. Now that I think about it, these aren't even direct multiples of 2 of each other. They're supposed to be. They're supposed to be perfectly, right? If you stacked, so if you took a square here, right, and you stacked 2 square pieces on top of this side by side, there would be a small gap. Or like this is longer than 2 by 2s, regardless. So this whole time, all of the dimensions have been wrong. The pocket's still good. It should be 18 wide. Wide? Why should it be 18 wide? It should be 16 wide. Oh, okay. I'm glad you made a mistake and it's not me neglecting something. Now, if we take a look at these, they're going to be wrong still. Here we go. Do a vertical, horizontal measurement here. It should be 6. And then this one, 5.7. I hate that. I have no idea what this is for. No, 24. What are you talking about? Cool stuff, Len. Hey, how's it going, Top? Look at this. We have made, well, we are making, how do I put this? We tried to make Lego. The tutorial we were using was using totally the wrong dimensions, so I'm trying to fix the dimensions. But it Lego. And all of this is breaking because we're not. What, why 24? Seriously, what's wrong with you? Are you okay? It should be very interesting. Thank you. It's 48 long. Yeah. That's what it needs to be. No, it's not. It doesn't need to be 48 long. It needs to be 32 long. I'm about to stream, so I'll catch you later. All right, man. Have fun streaming. I have a problem. 48 divided by 2. I don't understand your point. What's 48 long? I don't understand where you're getting these numbers from, so you're saying 12 between studs. The whole thing is wrong. The outsides. Actually, technically, yeah, the whole thing is wrong. There's no way. I refuse to believe that any component of this is right. I believe this. I believe these kinds of things. Just find the dimensions of a 1x1. The studs are 1.7 tall. I think that's the only thing that they managed to get right. P is this distance. H is the height. Which is, this is the height of this. Okay, I'm starting to get it. So looking at this, the stud is supposed to be 1.7 millimeters tall. The height is supposed to be 9.6 millimeters tall. The square measurement of a 1x1 is now why is it minus 0.2 millimeters? What's minus 0.2 millimeters? We also learned that the diameter of the stud is 4.8 instead of 7.2 like we had. Maybe it was just... I'm going to go back and read the dimensions a little closer. Because I think they said, hey, these aren't the real dimensions. It's 1.5 times bigger than the original. We found it. I could measure my own. It's supposed to be 1.5 times bigger. Yay. Oh, that took way too much effort. All right, well. We're just gonna discard the changes. Yep, this is 1.5 times the original. That's the point. Yep, okay. Makes sense now. All the dimensions work out now. Except for the fact that it's slightly off. I have a problem with these, man. I have a problem with them. We'll answer top when I get out of streaming. I saw that Top sent me a DM. I apologize, Top. So anyway, there's this. We're done with this. I'm going to move on to something a little bit more complex. Go ahead and close that. I've done this one, and now this one. Let's do this one. Let's create a wiffle ball. Do the airplane. Do I look like I want to do this airplane? Do I look like I want to do this? I don't. I don't want to do this. The aeroplane. I don't want to do this. This is garbage. Why would anyone want to do this? I really get to feel myself being an aerospace engineer by making an airplane in FreeCAD. Yes, I see. No. No! I'm doing this. I'll probably do that one after this one. And then I'll try and make some modifications to it to make it more real, and less accurate, I guess. But we'll start with a wiffle. File new, switch to the park workbench. I think that's this one. Yeah, that's this one. Press the 0. There we go. Now we're isometric. Press the View Fit All button whenever you add objects in, or pan and zoom through views of the elements. Huh? Huh? Oh, okay. I see. Hold control when you click to select multiple items. If you select something... Oh, this is just giving me tips, I guess? Insert a printed cube by clicking on box. Box. Easy. One simple trick to create box. Change the dimensions in the data tab of the property editor. 90, 90, 90. Got it. There you go, and boom. We did nothing. Nothing happened. In the data tab of the property area, click on the placement value so the ellipses button appear on the right. Press on the ellipses to launch placement dialog. Change the translation values, -45. Okay. Nothing happened again. Repeat the process, inserting a second smaller cube by clicking on box. Box. There it is, cube 01. In the tree view, oh, I already did that. Wow, I'm such a go-getter. And change the dimensions of place and the placements like the previous object. 80, 80, 80, and 40, 40, 40. Got it. 80. There. It's alive. 80. Oh, double cube box thing. We did it. And we're promptly going to remove its life. Oh no, it's disappearing. Say goodbye. Here it goes. Goodbye. Rip. Okay. Next. Change visual properties. Previous operations create a smaller cube inside a bigger cube. To visualize this, we can modify the view properties in the property editor. Property editor. Oh, view. There we go. Found it. Dumb. Be dumb. Oh, wait. Jesus. Okay. Change the color of the inner cube to green. There we go. It is now green. As you can clearly see, the inner cube is green. And then also change the value of line width to 2. It knows. The program knows. Select cube, larger of the cube. And then change transparency to 70. Right? Ah, it's there. You can now see green cube. I feel like it shouldn't be rotating. Or it shouldn't be shifting back and forth if it were truly centered. But we're just gonna bypass that. There we go. Insert primitive cylinders. That's me, I'm primitive. Select the cylinder in the tree view. Change the dimensions of data. We have a cylinder now. As you can see, we clearly have a cylinder. Go to the data tab. Radius to 27.5. Height to 120. Put a 2 there. Ah! Hello. A placement dialog. Nice. We're coming up with lingo for things. Change Y to 60. Rotation to rotation axis with angle, axis to X, and angle to 90. Okay, so wait. Y to 60. Y needs to be 60? Positive 60? Really? Okay. And then rotation axis with angle X, and then this needs to be 90. Oh! So it goes, boom. Yep, got it. Understood. Okay. We create another cylinder. This one. Menu edit. Duplicate selection. Oh wait. Maybe I didn't need it. Oh, okay. Yeah, so now I just, okay, yeah, I can actually just delete both of these. And then go back to here, and then go into edit, and then do. So now we have two cylinders that are the exact same. But in cylinder 1, we need to change the placement, right? Minus 60 on the X. There we go. And then Y needs to. Oh, wait. I skipped this whole step here. Okay, I see. I see what's going on. Actually needs to be 0. There we go. And then we just do that process again. Duplicate it again. Get this one. Go into the placement data again. Change this key. And instead of this being, this needs to be 0. It needs to be minus 60. Not equals 60. Minus 60. There we go. And this is now this. Wah. I don't know why it's having us change all the colors. I'll probably still do it. Smaller cube in the tree view, change the transparency. In the view tab, change the value of the transparency. Oh, okay. That's cool. Go back to the model view. Cube 1. View. Transparency. 70. Enter. Off of it. Nice. Select cylinder. Choose our red color. Cool. Red. Okay. Cylinder 2 needs to be blue. Or the second cylinder. Cylinder all 1. And then I'll just do this one instead. Nice. They're totally different, but I don't care. Select the 3 cylinders in the view tab. Also select the and also change the values of line width. They're already line width 2. Solid cylinders that intersect themselves and the solid cubes. Yep, they're there. Looks exactly the same. If you just change the orientation. If I just go wait. I don't think I can. Okay. Use and cut. In the tree view, select cube 1, the inner smaller cube, and the 3 cylinders, then press fuse to create a fusion object. They're fused. Then perform Boolean cut of the cube and the new fusion object. So, cube 1, these guys. What does fuse look like? That's what it looks like. This? No, this. Nice, we did it. Fusion. And then click on this guy. Wait a minute. Wait a minute. What happened to the blue one? Right, and then you get fuse. And then the blue one disappears. Huh? Try fusing 3 together and seeing what happens. It disappears. Let's try fusing just these 2 together. It's like rotating this when it does it. The overlap. Okay, so those fuse properly. BRB? Alright, so you see. Yeah, it's rotating it. Which means I have an idea. Okay, I had to manually rotate things. And now we can fuse these two fusions together. And finally, we got it. Alright, and then we click on this boy. Cube first, and then fusion. Then press cut. This will create a cut object. First, and then fusion, and then cut. Create a cut object. The order in which you select this object is important for the cut operation. The base object is selected first, and then subtracting object comes at the end. Yep. If the colors look strange, select the new cut object, go to the View tab, click on the shape color value, open up the select color dialog, choose gray color, also change the value line. Yes, the value. Go, click the cut, go to the view. There. Good enough. And then the line width to 2. Which is also true. Nice. Now we will create more cubes that will be used as cutting tools to trim the corners of the previously obtained cut object. Oh, interesting. I don't even remember what this thing's supposed to look like finally. Okay. Alright. Alright. I'll roll with it. I'll roll with it. Click on box. Select key. If we actually click on box though, we should be able to see it. From the front. There it is! This is the origin. Which is why this is not centered on the origin. Change its dimensions and placement, huh? 140, 112, 112. Right, 140, 112, 112. Negative 70, negative 56, negative 56. Got it. There we go. We go again. New cube. This cube needs to be 180, 180, 180. Right? Yep. And then translation data needs to be -9, -9, -9. Okay. And then we want to duplicate cube 2. And then cube 3 for some reason. And then you can modify the view in the properties editor. Yeah. Like the cut object, we already changed its color. It's not the base color. View transparency to 70. View 70. View 70, and view 70. There, now we can see all the way to the base, and it looks just like this. Press 0, and then this, there we go. Cutting the corners 1. Open the placement dialog. In the tree view, select 2 and cube. Dialog. What? You're joking. That doesn't work. That does that? Okay, well, whatever. You edit. Duplicate there, and they're also transparent. We're good to go. Everything's good to go. Everything's good to go. 0. You can hit center, and cube 2 and cube 3 go into the placement dialog. Apply incremental change. It's set to 0. Notice that all translation values are set to 0. Change the rotation in the rotation axis with angled axis X. Angle to 45 degrees. Okay. Apply. Okay. Back in there. Go to Z this time in a 45. You do minus 45, I think. Just listen to it. Listen to it. Just listen. Change the rotation axis to X, angle to 45. Click apply. This will apply rotation and reset the angle field to 0. Change rotation again. Now the X is the angle 45. Apply. This will apply rotation and reset the angle field to 0. And then it just says close. Apply. Oh, come on. Yeah, let's just start from here again. Placement dialog. Apply incremental change. Set the axis to X. Change that to 45. Hit apply. Set the axis to Z. Do 45. There we go. Hit apply. Hit OK. In the tree view, deselect object before. And press cut. This will create cut one. Hollowed. Like cube 3 first and then cube 2. So cube 3 first and then do cut. That will make cut a 1. Go here, go to visibility, false. Or press space on the keyboard, select cut 1, click on the shape color value and select. Yeah, that makes sense. I see what it's trying to like visualize it for me. Oh, it's wrong. Oh, it's really wrong, and I don't know how. I think... Okay, if I grab cut 1 here, go to data, go to the placement, like Y, I go to 45. Something's wrong. Oh no, I think I'm gonna have to start over from the end of the first chunk. Oh, what happened? This is supposed to be rotated. I'm just gonna hop in here, actually. And rotate it in the x-axis 45, see what happens. That's Y. Can't have that. And it's definitely not Z. Although, actually, Z would technically work. It's just not the angles that we need. It's the outer 4 here instead of the 4. Oh, yeah. So it's this, right? So actually, I've done this step now. And I have to figure out how to do this one with the other one. So that's how this is supposed to look, right? This is the second one, actually. The second one. Somehow we got here. And then I actually have to make that one invisible. Make these visible. And then do... It's telling me to make the translations and then cut. But wouldn't it be more simple to cut and then make the translation? Let's try that. Then I need to rotate it that way. That should be an x negative 45, right? Maybe it's a y 45? Maybe it's another z45? No, that's dumb. Yeah. Apply incremental change. Wait, 450. Oh my goodness. This tutorial sucks. Try doing an X and a Y of 45. See what happens. We did Y 45. Apply that, and then let's do an X 45. Apply that, and it is scuffed. Oh. How am I supposed to rotate this way? It's not even on an axis. That means I did the wrong rotation first, right? So let's take this and move it back. Oh, what I want to do. Reset it. We want to move it, tilt it backwards, and then over. Go into here, cut here. We go apply incremental change, X 45. No, we don't want X 45. We want Y 45. That should be fine. Apply. Then we go Z 45. Apply, and we hit OK. And that's not right. Okay, so we have this. We want to rotate it this way and then that way, but that doesn't work. So I have to rotate it. How do I have to rotate this? "45 degrees this way." But then it's like a 45 degrees this way, which is not on an axis, right? I want to try something. I can do my own vector. So if I do a Z rotation with an incremental change of 45, and then hit apply, and then I do a user-defined vector of x1, y1, which is in the same direction as x and y in equal parts. Oh wait, no. If I do all three, then it's going to be a weird rotation. 110 with an angle of 45. I hit apply. Oh, okay. Oh, I am a genius. Oh my goodness. I am so glad I went to college for 4 years to get a piece of paper, because it comes with knowledge, and that knowledge helped me solve this tutorial, which is just written wrong. So now if I make this one visible again, we've got all 8 corners chopped like we want them to be, which is perfect. Perfect. We did it. We can move on to the next step now. Gee willikers, it's what we have. My goodness. Okay, then in tree view, deselect the objects and select cut first, then cut 1, press cut. This will create cut 3, and then do the same thing, cut 3 and cut 2. Cut, then cut 1, and then hit cut, and then cut 3, cut 2, hit cut again. And we've done it! Real objects don't have perfectly sharp edges or corners, so applying a fillet, a nice fillet, a fillet. This is a fillet in engineering. It's a fillet in cooking. It's a fillet. Ooh. In the tree view, select cut floor, and then is this the fillet tool? Fill up the selected edges of press all, and then choose as fillet type, choose constant radius and set that radius constant radius. Set that radius to 1. Press OK. And boom. In the View tab, change the value of the line width. The fillet, and then we go over to here, click on it, and it's already aligned. Perfect. We did it. I'm going to leave this here in triumph. Save. Call it Wiffle tutorial because it's a wiffle ball. Oh, it's spelt with an H. I'm a failure. Go ahead and delete that. There we go. The wiffle ball has been completed. Oh, that's so cool. We did it. We did it. That was needlessly complex, I think. Oh, there we go. Ah, oh, this is a really crappy wiffle ball. It kind of reminds me of a socket box from Diablo, the Diablo franchise. Kind of, just a little bit. See? Kinda. If the corners weren't cut out, it would look more like it. So the wiffle ball tutorial is done. This one's done. And then it's time to do the arrow point, as Mr. C. Racine suggested. This looks like it's gonna suck. Aeroplane. Did you see the finished products you were seeing? The wiffle ball. The finished product of the wiffle ball. Did you just come back? I'll open it again. This is our wiffle ball. Kind of looks like a mask. If you look at it like this. This is like a mouth and then eyes. Like a fish, kind of. Like a skeleton fish, too. I'm weird. You should have seen it. So, the angles that they gave me on the wiki were wrong. They were just wrong. Creepy. Yeah, creepy. I did the rotations as they said, and I couldn't figure out why it wasn't working properly. It was like rotating at weird angles, and it wasn't going where I wanted it to go. So I had to create a new. So what you can do, and if I go to the fillet here, and I can go to the data, and I can go to the placement data, right? I can change the angles on the three axes, which are right here, right? But I needed to change the angle on the axis that's like between the X and Y. It allows you to define an axis based on a vector, So if I did that and I put it in 1 1 0 to create like the product of the X and Y axes, and rotated it along that to get what I needed. It was super cool. Nice. Go away. Stop eating those. Anyway, new project. This time, aeroplane. Okay, I'll leave. No! My dad keeps buying me tins of almonds, and I keep eating them all in one night, and even though it's like 6 servings. So I need to like temper myself and stop myself from eating so many almonds in one sitting. Select it from menus via View Workbench Part or from the Workbench selector. This is the Workbench selector. Part. That's a lot of salt. Is it? Well, I drink a lot of water to compensate. Like an absurd amount of water. Create a new empty document. Switch to axonometric view. What the? Oh. What? Oh, okay. Weird. Anyway. We'll just use this view, I guess. Ensure that you have combo view showing. Via view. Panels? Combo view. This is obviously old. Select it by selecting the cylinder. Create a cylinder button. Yeah, there we go. Select the cylinder. The radius needs to be at 2, but the height needs to be at 20. There we go. Looking great. Placement. 3 dots appear, click on it. This is written by a completely different person. And it really shows. We are now going to rotate the cylinder so that it is lying on the x-axis. To do this, we need to do a rotation around the y-axis. Y 90. Oh, 900, yeah. Yeah, that makes sense. That would happen. I feel that. Okay. Okay. I like playing the rotating view with rotating the view at this point and often, so by all means do so. You should find the seam of the cylinder on the underside. Yep. Now I'm going to modify a box, so click on the box button. Box! Project viewer, change the height to 1 millimeter, length to 5, and the width to 20. 1, 5, 20. Length to 5, the width to 20. Oh, the height to 1. Okay, okay, buddy. Put them in the right order, please. There we go. Now I'm going to merge these two shapes together with a... Oh, wait. Click on placement, go to the tasks viewer, using the translation box, enter y equals -10, z equals -1. Yep. Y is -10. Z is -1. Hit OK. Merge these two shapes together with a Boolean operation. Boolean button in the tasks viewer that will display Boolean operator selector. Boolean. Ugh. Union is selected, and the cylinder blocks are each ticked once. Do shapes list. Cylinder and click on apply, click close. You now have a single object called view. Get it from this perspective. Yep, there it is. 0. Let's add one more box to finish our model. Create a box. Here's our box. Nice. Length, height 5, length 3, width 1. So the length needs to be 3. Width needs to be 1. The height needs to be 5. Nice, that's done. Now we go into the placements. Y is -0.5. Okay. Do it the quick way, yep. Rename it to aeroplane. I think the wings need to be moved forward a bit, but if I select aeroplane, try and change its X placement, translation, the whole thing moves. I only want to move the wings, so I cancel the placement. Band view here. Fusion at this cube. on box and get its placement in tasks. Notice that I change X translation to 3 and click apply. That's better. Three and apply. That's not better. That's not better at all. Rotations. Click on the aeroplane. Placement. As. In the rotation section, change where it says rotation axis with angle to Euler angles. That's a lot easier to work with. You can have Euler angles? We do! Yeah, okay. Pitch and roll, yeah. Yeah, positive rotations are clockwise. Positive rotations are, when viewed from the origin outwards along the positive x-axis. Positive rotations are counterclockwise when viewed from a positive axis towards the origin. Although the three labels are yaw, pitch, and roll, it's not really what they are. Yaw, pitch, and roll references the body coordinates of the object in 3D space. The labels here should be heading, elevation, and bank, or even azimuth, inclination, and bank, because they actually refer to space coordinates of the 3D system. These are Tate-Bryan angles. If you want more information, then try Euler angles. I went to college for that. I don't care. With aeroplane and its with the aeroplane in its present positions, simple rules apply. Yaw is rotation around the z-axis, i.e. left and right. Yep. Pitch is rotation around the y-axis, i.e. nose up and down. Roll is rotation around the x-axis, i.e. wings up and down. Yes. That's fine to start with, but it's not going to be true later. Okay, yeah, so the only gripe I have with making this is that with this in general, right, is that it doesn't even begin. I understand that this is CAD made by what I would imagine to be mechanical engineers, right? CAD tutorials made by mechanical engineers, perhaps professors, or even high school teachers. Like, this isn't very complex. But they make an airplane, and they don't even begin to talk about, like, any sort of aerodynamic principles. Like, this might just me being a snob here, but, like, they don't even begin to say, oh yeah, let's put the, even just as simple as saying, let's put the rotation, or let's put the center of the origin. Let's put the origin, right? Like, where we would pretend that the aerodynamic center would be. They don't say that in the tutorial anywhere. And, like, I could take this whole thing, right? I could take the whole airplane here. It says you do that later on. Alright, pitch roll labels are not really suitable. Change the roll number to 90. Yaw should move the nose down. Airplane. It says you do that later on. Are you talking about this right here? Because this is just saying, oh yeah, just change the location and see what happens to the angles as a result, right? But also in those GIFs, I mean, yeah, the GIFs say, you can see with the GIFs that it does it, but it's never talked about, right? It's never said, okay, well, to make it more, he says, oh yeah, let's make it more realistic by moving the wings a little bit more forward. Which, at this point, this is more of a missile than a plane. Right? It's more of a rocket than a plane. Pick your poison. So it's like, technically moving them forward is less accurate for a rocket. And keeping them on the back wall here is actually better. That being said, of course, there are some other things that you have to worry about with a missile, whatever. If we wanted this to be accurate, we would put it at the top. We would move the wings forward. We would get some semblance to make it look even slightly accurate, right? So I would go into here, go into my little cube here, go into the placement. Instead of 3, we would want to do something like we would fiddle with it. 13's too much. Maybe 8 is good. 8 still is, that's better. That looks more realistic, right? We want the D is currently -1. We want it to be something like +1. Maybe something like +0.8, right? Because we want the wing sitting on top, right? And with just the, not even talking about things like cross-section of the wing, right? Airfoil. We now have something that looks a lot more plane-like. Going with a high wing! Yes! Yes. Yes. I am going with a high wing. High wings are at least popular in common. There are a lot of low wing planes, but if you look at any of the big boys, go to any airports, you'll see a lot more high wings than low wings, just because different use cases. Right, so, you know, high wings make sense. You can have it low, right? Having it low is fine, but having it way far back and saying, oh, moving it forward a couple of millimeters and then saying, oh yeah, this looks great, perfect, deceptive. I actually do like it at 10, don't I? Moved, right? Oh, I clicked away. There. Okay, there we go. So, you know, it's like, and we could add a nose. We could actually, I do want to see if I can't, like, do this a different way, right? So let me, we're halfway through, and I've basically exhausted all of the tutorials that I want to go through. Right? Maybe the screw one would probably be beneficial too, but I feel like that wouldn't be a little boring. So I want to try doing something on my own. Oh, yeah, actually, this one would be fun. This one would be fun. We'll investigate this one later, but I kind of want to go down this rabbit hole real quick. So I'm going to go ahead and save this. Create a new one, close that. And I want to do the part design. I want to do part design, right? Right? I want to do part design. I want to see what I can do. I want to see what I can do. Let's create a new sketch. We want the, we're in the XY plane. I want to be, yeah, this is fine. The XY plane. Actually, no, I want to be on the left. The YZ plane. We're now in the YZ plane. And I do, so you can do curves, you can create arcs, circles, you can do splines, polylines, points, regular lines, right? My biggest question is it possible to import a set of data points? By control, right? So I can do something like this. Holy cow. Conic, ellipse, arc of ellipse by center, arc of hyperbola by center, arc of parabola by focus, vortex, and point. Sick. Cool. I can do that much. Oops. Oh, I see. That's clever. Major axis, minor axis. That's cool. Hello? There we go. I wonder if it's a plugin. It's probably a plugin. Right? So if we wanted to do FreeCAD import data set for sketch, right? I don't think this is what I want. What is an SVG file? Oh, maybe it is what I want. Maybe it is what I want. So I guess if I saved it as an SVG file, I could. Right? Here we are. Good old 4412. The beautiful polars. Oh my goodness, I love all of this. So instead of import dataset, Here we are. Spline or curve from list of points. A forum is always a good place to look. List of points. I'm trying to model a wing in FreeCAD by sketching the airfoil cross-section, then extruding the sketch to create the wing. I am used to SolidWorks, which is fun called curve through XYZ or something similar. Allows you to specify a list of points with 3D coordinates or to import a list of points from a text file following format. Don't know of a GUI command, but draft.makeBeastLine points list in Python should do it. Okay, just use Python, lol. Sorry, but the link macro is exactly what I needed, thank you. Oh, wait. This macro, when run, will provide the user with a file browser to locate and select a .airfoil text file. Once selected, a chord length is entered upon it. Pressing the OK button, properly scaled airfoil is produced. But, unfortunately, it's a macro. Which means we don't have it in the base. Which is unfortunate. Sad. And it's a Python macro too. Yuck. I'm just kidding. I love Python. I'm just not very comfortable and familiar with it. Python would also be fun and interesting to learn, I think, on stream. Anyway. Oh, so nice. Importing airfoil data. FreeCAD can import airfoil data such as files produced by airfoil. How to? From the file menu, select either open for a new document or import for existing document. From the open or import dialog, files of type. Select either open. Oh, I can do CSV. Do an Excel spreadsheet, but I'm looking for a dot at. Oh, here it's common airfoil data. Select your file and click open. When opening airfoil data files, FreeCAD reads the file and imports them in FreeCAD units. Airfoil data files provide XY coordinates in numbers between 0 and as a result, the imported airfoil will have a chord length of 1 millimeter by default. Here's a truncated sample of typical airfoil.dat file. Notice that all points fall between 0 and 1. Yeah. Enhanced import. Also macro available that will import the airfoil data using a user-defined chord length. I don't care about that. I just care about getting that going. So I can go here. Source dat file? Can I download the source dat file? Am I just dumb? I've used this website before, and I've used this website before, and I have downloaded files from here, or at least copied and pasted them, but I don't remember how to. I'm looking for the NACA 4412. Here it is. And it just does this! On the right side? On the right side? Are you talking about these right here? They're links. CSV file of coordinates? Okay, but that's a CSV file. I suppose if I do that... Right? I can actually just go into here, and instead of doing common airfoil data, I can do CSV format. And then... What file type do I want? I want a DAT file. Try an SVG as well. And if I go... I can open an SVG file as geometry. I got text somewhere. What is this? Oh my goodness. It even gave me the axes, so I can actually maybe get rid of all of it. Oh wait, no, sorry, wrong button. And then path 001 as well. And then all of the text here. Nice. Now what can I do with this? Technically it's a path, right? So if we go right here... We've always had this problem. I've always had this problem since, like, sophomore year of college. This is, like, a known issue. Airfoils are not complete objects. They're, like, just literally just a line. True airfoils. So it's like, the solutions are wrong. Everything's wrong. Straight line. Just straight line down. So wait. The question is, right? How do I work with this? How do I work with this? So maybe this just imports it as... Okay, so wait, what happens if we... we would back out of here for a second. Back out for a second. And then we file, open it as a drawing. Perfect. Exactly what I needed. So my problem is... I don't think it's possible with this tool. I think what I would have to do if I actually wanted to sit down and do it is I would have to go into my sketch here and, like, essentially make 20 segments, right? Just add one more point to the CSV. Yeah. No. What I'm saying is the CSV is one thing, right? And technically I'm not using a CSV. Technically I'm using this. Right. The what type file is this? File is this? SVG image file. And it's gathering the data from the SVG image file. Right. So it's not exactly a data set, or at least an easily accessible data set. It's literally just an image in a sense. So it's not, but that's on one side of the thing. The other side of the thing is this actually isn't a sketch either. It's like an object. Right? What is this? Labeled a path, but what is it? Right? So what I would have to do to make it, right, is I would have to, I don't know, probably create a spline with a bunch of points similar to the number of points, exactly the same as the number of points in this, right? Right? And then use those points. Oh, I can't even use them as external geometry. So I don't know how I would go about making this as a sketch. One option is to take this data set, right? And manually, so one option is to create a bunch of line segments, right? Not even a spline anymore, just a bunch of line segments like this. Go boom, 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 just like randomly, however many times there are points, right? And then say, okay, well, now I need to measure out the height and width compared to the origin, right? So, like, we have, okay, where did that go? Disappear? Did I close it? I must have closed it. Okay. I closed it. So, this is the airfoil surface. I would have to use these, right? I would have to use these points. And this is like a percentage, right? Well, technically it's in millimeters, right? And I would have to get these points and go horizontal this point, and here needs to be 100, right? If I wanted to be a stubborn fool about this. And then the y-axis needs to be 0.13 millimeters, no cap. 0.13, right? And then I go to the second point, and that one's y is 1.47, and its x is 95, right? And look at that, they're the same angle. It works, right? Do that with a third point, and it gets excruciatingly chaotic. Nope, we don't want that. Vertical from here to here, please. Like 2.71. 2.71. Right. Can you extrude a surface from the path? No, I can't. That's what I tried at first. Right, so let me finish with this point here, and then I'll go out of the sketch, and then that needs to be 90. Right, so, and then I can just, like, hit escape, and then go over here, space that out, and I can click on this path here, and I can extrude. Failed validation, broken face. Right? It's just like trying to do it with this one. Hide the whole thing. I can't use this for anything because it's not a solid shape. Literally my only options are, my only option is to do this nonsense, right? Where I go into a sketch here, and I make all of these dimensions work. Which is mind-bogglingly insane to do. right? And it would go, and it would go, and then it would go, and then it would go, right? Because it goes up and then it goes down. And I would do that. I would do that for the whole thing, beginning to end. And if I wanted to change the size of it, I'd have to go back through every single point and change the size of it. That being said, once it's actually an object, I could probably just change the size of it without having to worry about changing the sketch too much. That's how you would do that. That's how you would make an airfoil. You would get the data and you would input it by hand, which is crazy. Or you download a plugin or whatever, right? Need more water. Like how SolidWorks can do surfaces or bodies. I don't know what you mean. All right. But I'm petty, so after 90, I'm actually going to take the data file and put it over here. After 90 is 80, surprisingly enough. And then the vertical is 4.89. And then this is the next point. 70. Right? And then the next point, this direction is 6.69. Hey, that's nice. Right, there we go. I would say you get the point, but I'm kind of going down a rabbit hole here, and I'm kind of interested in continuing. If you guys are... Your guys' eyes are bleeding, and you want me to stop, boring, or... and you don't want me to continue, then let me know. Because I'm probably going to just continue for the heck of it. These 2 points need to be 60 apart. X. And they need to be 8.14 apart and Y. And it's coming together. Oh, it's taking shape. This one, 50. And then here is 9.19. Oops. If I put negative, will it work? But don't tell me there's a negative in front of it. Oh! That's better. Oh yeah, it's all coming together. Look at it. Is there a way to hide dimensions? Just try and move all of the points into the axis that they're supposed to be in. Or quadrant that they're supposed to be in. And if you notice, we're very, very far from the number of points we need. But it looks great if you take out the massive number of dimension. Under constraints sketch with 16 degrees of freedom. Wow. So the last one we did was 50, now it's 40. And this here is, as one might expect, maximum thickness line. Obvious, because that's how airfoils work. At least NACA 4-digit airfoils. If we go to 40 on the other one, it's minus 1.8. And this one's plus 1.8. Or, sorry, plus 9.8, I think. Yeah. I feel like that's not right. Just frankly. It'll probably make more sense once I have the whole thing mapped out, what it's supposed to be and what I'm supposed to do. What I'm supposed to figure out. And know, just from my science degree. My degree in science. You notice our degrees of freedom are slowly going down before we put them back up again? This one then needs to be 30, right? Yeah, 30 and then 25. 30. And then this is 9.7, I want to say. 9.7. No, yeah, 9.76. 9.76. Boom. And we started declining. This is now 25. And then this one is actually 9.8. No. 9.41. There we are. And we're on the sick decline. My download. What is the old blue? It's... I want to say it's like here. Where is FreeCAD? Let me try and find FreeCAD. We could open file location. Am I saving them to my... I don't know where I'm saving these. Oh well, I'll figure it out. I'll save this probably just to my downloads folder, I guess, since that's where it is. Because that's where the CSV file was. That sucks. I need to stop going down that rabbit hole. Goodbye. This point is the next point that needs to be constrained. Where the last one was 25, the next one is 20. And then this one is 8.8. Yeah. If only I could hide these dimensions. You can actually see that it looks like a airfoil. Okay, that's it. How to hide dimensions in FreeCAD. Hiding dimensions. Sketch virtual space switch. Sketcher toolbar. Drop down menu, sketch, virtual space. Get a sketcher toolbar. Sketch. Virtual. Sketch virtual. That worked. Thank you, Google. Thank you, Dr. Google, and Foreign Man, for helping me. We love Dr. Google. And now I can just continue on without worry. It's gonna be a mess when I look at it later. But, you know, that's fine too. 15? Yeah, 15 is next. And then I immediately forget where I was. That's classic. And then the height one, 7.89. Boom. It looks nice. I have to do this for all the points. I'm literally not even gonna get done with the top half with this number of points. Which means I'd have to do this. Something like that. And then edit all of these points down. And make sure that, like, pick this point and have it coincide, like, be coincident with this point. So, like, boom, boom, coincide. Something like that. Actually, exactly like that. That was beautiful. Now there's 47 degrees of freedom. Love to see that. This one needs to be 10. And then 6.59. Oh, wrong way. .59. And then this one needs to be 7.5. And then 5.76. This one is then 5. And then 4.73. You gotta do things the hard way at least. And then this one is 2.5. Oh! That's what I did. Okay, I figured out what I did. I didn't click this. 2.5. And get 3.39. 3.39. Next point is this one. You get 1.25. Ah! 1.25. And then this N 2.44. It's the fabled 0, 0. Oh wait. I can do this. I can do this even simpler. Bad. Boom. Top half's done. Now it's time for the bottom half. It's gonna have the same number of points, so we're halfway done. 1.25. I'd put these all on top, by the way, because the next answers are negative. 1.4. 1.43. 2.5. 3. Oh, sorry, negative 1.95. There we go. Next one is 5. And then negative 2.49. And then we've got this one here. Which is 7.5. We're just making our way forward again. And then 2.74 is there we go. This one is next. It is 10. And then 2.86. And we've got this, which is 15. And 2.88. And this one's 20. Oh, it's gonna go fast now. Then we got negative 2.74 again. Yeah, those appear twice. And then we have, after 20 is 25. And then Negative 2.5. Just straight up negative 2.5. Then this one gonna be 30. And then 30 is negative 2.26. And 40. It's in increments of 10 now. Got negative 1.8. $50. Negative 1.4. $60. I hope I picked the right point. -1. I knew it! So I'll have to set the vertical one first. And then the horizontal one. What are the odds? There we go. And this one. -0.65. $80. That's -0.39. And then this one's 90. With -0.22. This one's 95. With -0.16. $55, $56, $100, $102. Why is this set to be vertical? Weird. Wait, did I? Okay, that's already constrained that way. Good to know. Then we just constrain it this way. -0.16. Weird. I can't believe it. I cannot believe it. 100. We have exactly the right amount of points. -0.13. And then this one is also 100. And then its vertical measurement is 0.13. Right? Actually, wait. I'm gonna remove both of those constraints, and then I'm gonna actually take this point and this point and make them. And now it's fully constrained. We have ourselves an airfoil. Nice. I'm just gonna download it here. Airfoil underscore shenanigans. Which is exactly what that was. But it's closed. It is not technically a true airfoil, you're correct. But it is a fully constrained one. Which means we close this, delete this stupid path thing, and we have ourselves a sketch that we can then metric to plane. We'll make it 100. Make it 500 in each direction. Easy. Now I wonder if we could instead do something like this. Can we loft it? Oh yeah, we only have one profile. Where's the twist and the taper? I was trying to figure out how to do taper. Some quick tapering. So the twist, the taper, the dihedral, yeah, all kinds of stuff. Yep. Yep. This is our wing. We did it on the wrong plane. I can just fix. I can honestly just fix that. I can't fix it. I can't fix it. I can't fix it. There's no view I can put this in to make it look. Except a custom one. Even then. That's good. Ish. Oh, yeah, that looks great. I wish I could get rid of these ugly lines. Okay, we shenaniganize with airfoils. I wonder if I could... This. Create a new clone. Oh, okay. Select an edge, face, or body from an active body. I did. I selected all of them. I want them all to be filleted, but I guess that's not possible. I would probably break it, to be honest. Okay. This is the process you would have to go through to make a wing by hand. I will never do this again. I just wanted to today. I just wanted to see what it was like. And I learned my lesson. I don't want to see what it's like anymore. Ever again. Oh, you guys can see my little itty bitty bit of Discord right here. Funny. There, now it's gone. Okay, airfoil shenanigans is done. What should we work on for the last hour? Any suggestions, see, Racine? Anything you want to see me attempt? Oh, I know. Never mind. I know what we can try and crack our heads in. If I change something else, right? Does it... Half? Oh, okay. Part? What's wrong with this? Okay, yeah, just be back my wing. I was thinking I could try and figure out how to do finite element modules for analysis or something like that. Like if I looked up right? Workbench provides a modern finite element analysis workflow for FreeCAD. Mainly, this means all tools to make an analysis and are combined into one graphical user interface. I'll be back in a sec. Okay. Workflow. The steps to carry out finite element analysis are pre-processing, set up the analysis problem, modeling the geometry, creating the geometry with FreeCAD or importing it from a different application. Okay. Creating an analysis. Okay, well let's begin. Actually, I'm gonna start over. Airfoil shenanigans. Discard the changes. Get rid of this. What is this? Oh, it's just NACA stuff. Okay, discard that. This. Discard that as well. Okay, here we are. Here we go. Let's start by part design. Actually, let's just make a quick part, right? Cube. And then we turn cube into plank. So let's leave the length the same. The height needs to be 1. Actually, we'll make it we'll make the height 10. We'll make the length 100. And we'll make the width 20. Actually, we'll make the length 400 and the width needs to be a least. Oh. Ah! Don't know what I just pressed. Needs to be 50. Okay, here is our plank. All right, this is plank. Plank. There it is. Okay, the model is done. Create an analysis. Adding simulation constraints such as loads and fixed supports to the geometric model. Adding materials to the parts off the geometric model. Creating a finite element mesh for the geometric model or importing it from a different application. Okay, solving. Run an external solver from within post-processing. Analyzing the or exporting the result. On Linux, since the workbench makes use of external solvers, the amount of manual setup will depend on operating system. So you can't use workflow of the FEM workbench. The workbench calls 2 external programs to perform meshing of a solid object and perform the actual part design, part other. So yeah, that's the solid. That's what I'm working. FEM work. So then I switch over to the FEM workbench, right? And analysis. Got this. Which is materials. Oh, okay. Right, for a fixed geometric entity. Then fluid section, no. Shell plate thickness. Beam rotation. Creates a process. Opens FreeCAD material. Density, okay. Poisson ratio. Ultimate tensile strength, okay. Young's modulus. Thermal conductivity, okay. Cost, oh, okay. Okay. Leave it at the fact that it's. Wait, is this just like a... Oh, it edits the material itself. Oh, I thought it chose material. Okay. material force? Where's aluminum? Here it is. The modulus, cool. Okay, a material has been selected. There's literally no definition. Mechanical constraints used to define a fixed constraint on edge face. Create gravity acceleration at self. Okay, so we have an aluminum. If I'm doing this correctly, which I am assuming I'm not, I have an aluminum beam, like a plank, right? A cantilever plank, right? And it's cantilevered, right? It's this whole side is totally fixed, can't move, can't rotate. That's what I hope that means. Okay, let's add a displacement. What's this? Plane rotation. Let's just chuck them all on there. Contact between faces. Force acting on a geometric end. Yeah, I don't want this moving. I don't want it moving at all. Okay, so let's assume that we have constraints. And it's under its own way, actually. Let's get rid of the self-weight constraint. I just want to see what happens. And then we need to apply loads to it, right? Mesh. Jeez, this is cutting edge tech or something? All is selecting a mesh dialog will be. Well, if I click on solid, then I click analysis, nothing happens. Okay. I don't know how this works. So I think in order to run the finite element module in here, you need to have a meshing software and a so you can, in the workbench, you can do materials, constraints, and loads, but you can't do the mesh or the solver. About a second. We'll have to figure that out. Play with it on stream at a later time. Back in a Salt plotting visual also be done in. Can't be done in FreeCAD. Not be done in FreeCAD. How do I apply a load? I want to apply a load to this. When it... I have to do that again. Oh. Okay. Figured that out. Is there a way to apply point loads? Weird. Select one, post-processing pipeline object. Click to make sure it's exactly what define create a clip filter, which function for you post-process. Apply changes to power directly, not recompute. Oh wait. Alright. Well, I think this is something that I have to figure out on my own. And then come back and show you guys how it works, I guess. I open this, it's gonna be blank, isn't it? Yep. Doo-doo! This must be some real cutting-edge stuff if it's still not here. Yeah, I just don't think it's possible to do it with... I know it's possible not to do it alone. That is exactly what this says right here, right? 2 external programs perform meshing of a solid object and perform the actual finite element problem. Which means I need to find a program that does finite element analysis, and it gives me a list of them right here. Calculix is 88 and Elmer. And then I need to find a program for the mesh as well, Gmesh or NetGen. Why I think that's why these are these are grayed out is because I don't have either of those. And then 2, these exist, they're allowed to be put in there, but I can't do it for some reason. I don't know why. Anyway, I don't think this is gonna go anywhere anytime soon. I'm gonna save this as FEM test 1. And I think that I'm gonna just call it a night early, half an hour early. This is something that I will probably get back to in like a week from now. Working on it on my own time and coming up with cool projects and things like that I can do. My ideal, well, while I'm learning this thing, I would like to be able to come up with little projects that I can do. I already have a few projects in mind, so I'd like to be able to like enact those and like work on them and figure out how to do them. So hopefully I can figure out some more projects, because I don't know how long the ones that we're going to take are going to take. But yeah, the whole goal of this was for me to kill 2 birds with 1 stone. I need to stop. The whole goal of this was to kill 2 birds with 1 stone. I need to figure out how to learn CAD and FEA, and I also need content for the stream, so I figured, hey, why not do both and do CAD content on stream and see how effective it is as a content generation machine. And I would say that we did okay. It's some just feedback that I was thinking about while doing all this stuff is one, FreeCAD isn't the best thing in the world. That's very obvious, so it's very difficult to... There are a lot of things that it's missing out on. And then 2, it's going to be very difficult for me to fill up time with things. The projects will either have to be more on the complex side, or I'll have to like do multiple small projects, because the things that I did today weren't necessarily not complex. They were pretty straightforward, but they had a lot of steps. But they didn't take long at all. So I will either have to make really complex projects or a bunch of smaller projects. I have a couple in mind, but I don't think they're going to take a full day unless there's something that I can't do, in which case I'll have to just scrap the project regardless. So yeah, I'll do some research and I'll figure out how this is. Apparently tomorrow, so I just got messaged by Top. I'll have to figure out what that's about. Tomorrow he said he wanted to do something. I guess we're streaming or something. He wants to play games with me or something, so I might stream that. Monday, I finally got a hold of Bookworm, the guy who I play who I played auto chess duos. And he said that he would be down to play Monday. I'll probably do Monday like 11 to, or sorry, not 11, 8 to 11 with him, which means the first hour I'll have to fill the time. I will probably play auto chess by myself. I have said it. I will probably play auto chess by myself because we were playing yesterday, literally last night, and I was having a blast and I was having a lot of fun, and we didn't even get to play duos for the first half. We were playing solo by ourselves, and having so much fun. So, look forward to that on Monday. Maybe I'll be playing with Top on Sunday or Saturday, and I don't know what I'm doing on Sunday quite yet. So yeah, that's basically what the weekend is looking like right now. I don't know if I'm gonna have this figured out by Sunday because I work tomorrow, I work Saturday, and I work Sunday. But I'll definitely work on it in the meantime. And perhaps by next weekend I'll have it figured out. And figure out how to do the FEA stuff, or how to do the plugins or the macros or the other stuff that's like not built into base FreeCAD. Because the important thing about learning a CAD software is overcoming these hurdles, and that's something I'd like to be able to do. I just didn't want to get into it today while I was figuring out the base of the program, and I'd say I have a pretty good understanding of the base of the program. But yeah, we're just gonna call it here because I don't really have much else for you guys, so I'd rather just, instead of making up half an hour of content, and that content being pretty subpar, I think it's just good to call it a night. So yeah, that's what we'll do. Thank you so much for coming out tonight, everyone. Oh wait, streaming tomorrow? I don't stream tomorrow. I just realized, so the top thing, disregard that. I don't know what we're doing Saturday. And I don't know what we're doing Sunday. Because I think Top's gonna, I don't know what's going on with Top. I'll figure out what's going on with Top. But he contacted me at a weird time where I was in the middle of my stream. So I couldn't properly respond to him. But yeah, at any rate, I'll figure out what we're doing Saturday and Sunday, but Monday for sure we'll be playing auto chess. I might also want to knock out another one of those games, so we might play Phasma, we might play Terraria, we might, I don't know what we're doing yet, but I'll figure it out by then. Anyway, thank you so much for coming out tonight, everyone. Shops closed. Meet me back here Saturday. We're going to be doing something and being productive and streaming. So yeah, I hope you guys at least enjoyed this content, and my rants about aerospace and all that. Or I'm going to do more of this in the future, so if you don't like that, I do apologize, but it's just something that I'd like to do on the stream and create little projects for us to do. My end goal for this channel is to become a science streamer, if that makes sense, like an engineering streamer where I make gadgets and gizmos and things like that on stream, beginning to end, the design process, the manufacturing process, all that stuff. So the coding, if it has coding and I can figure it out. So if that sounds interesting to you, then stick around long term, because I'm not going to be able to figure that out in a night. So anyway, thank you all and have a